Solving systems of equations. When you're solving a system of equations, you need to solve one variable at a time, right? So you're usually going to be trying to eliminate one of the variables so that you can solve for the other one. So let's see how to do that in this example. If I am looking to eliminate my x term, then that means I'm just looking at the x terms, right? If I'm just looking at those x terms, how can I get them to be opposites of each other, right? Opposites are like +5 and -5, right? Same distance from 0, but on different sides. So I want this 1x and this 3x to be opposites of each other. What can I multiply by to make that happen? Well, I already have a 3x here. So I could make this term a -3x. But in order to do that, I would have to multiply the entire equation by -3. So let's see what that would look like. I would multiply each term inside these parentheses, again, the entire equation by -3. So x times -3, so I'm going to do that first, would be -3x. And then y times -3, -3y. And then 5 times -3, -15. So now when I add these two equations together, I've accomplished my goal. I have eliminated x. These two added together equals 0. That's what opposites are. They're two numbers that when you add them together, you get 0, right? They're the same distance from 0, but on opposite sides. So when you add them together, you get 0. And then I can continue solving. -4 plus -3 gives me -7y. And 8 plus a -15 is also -7. And then I can divide on both sides by -7, right? And then I have that y is 1, right? So now let's look at this equation all over again. And this time, let's try to eliminate the y. So right now, from my y terms, I have a 1y, right, and a -4y. Again, I want them to be opposites of each other. The good news is they're already opposite signs, right? I already have a positive and a negative. So if I want them to be opposites of each other, I could multiply this top equation by 4. Let's see what that looks like. It's kind of like distributing, right? I'm going to multiply each term, including this answer, which we would call the answer that's on the right, both sides of the equal sign. Everything gets multiplied by that 4. So I would get 4x, and then 4 times y is 4y, and then 4 times 5 is 20. So this time, when I add my terms together, the y terms are the ones that are eliminated because they're opposites. So when I add them, I get 0. I add the x terms and I get 7x. I add the numbers on the right side, my constant terms, and I get 28. And then I divide both sides by 7 to get that x equals 4. Now, you don't have to do this whole problem twice, right? I just wanted to show you the difference. What if I wanted to eliminate x first? What if I wanted to eliminate y first? How do you know which one you should eliminate? The answer is whichever one is the easiest. Unless they're asking you for a specific one, like how would you eliminate x? If you have the choice, you want to go with whichever one looks like it would be the easiest to eliminate. All right, so let's try like a whole problem where we find both variables. Okay, so here we're just going to solve the system. So it's up to us which variable term we want to eliminate. I'm looking at my x terms. I've got a positive 2 and a positive 1. And then looking at my y terms, I've got a positive 1 and a negative 2. I think I'm going to eliminate the y terms. It's not really like one is a whole lot more work than the other, but these are already opposite signs. So that means I would just have to multiply this whole top equation by 2. So let's see what that looks like. I'll write it underneath here. So 2 times 2x is 4x. 2 times y is 2y. And 2 times 7 is 14. Now when I add these two equations together, as planned, my y terms will cancel, or I will eliminate them because they add together to be 0. When I add my x terms, I have 1x and 4x, so I get those, add them together, and I get 5x. On the other side, 6 plus 14 is 20. Divide both sides by 5, and I get x equals 4. Now, do I have to do that all over again and then this time eliminate the y's and the x's instead? No. No, I don't. All I have to do is plug back in. And I can plug back in to either equation. So if let's say, for example, I decide to plug back into the first equation. Since x is 4, I would replace this x with a 4. So 2 times 4 plus y equals 7. This is 8 plus y equals 7. And then subtract 8 from both sides. And I get that y equals -1. Or maybe I wanted to plug into the other equation, right? It's totally up to you. But let me show you what that would look like. Here's my other equation. I know again that x is 4, so that gets plugged in right there. I would have 4 minus 2y equals 6. Subtract 4 from both sides. -2y equals 2. Divide both sides by -2. And y is -1. Either way, right? Either way is fine. Or if you don't like plugging back in and solving, you could start from scratch and decide to eliminate the x's this time. Any of those options are on the table. They're all good options and they will all give you the same solution, that y is -1. So the solution to my system is a point. Okay, so the point that is the solution to my system would be 4, -1. This is my solution. Not this by itself, not this by itself, but together, the x and the y that you found written as a point. So let's see what that looks like in a graph. So here I have two lines graphed. I have a point plotted right at their intersection. What can we say about that point? Well, we can say that that point lies on both lines. And because it lies on both lines, it is the solution to this system. This is what a solution to a system looks like. It's the intersection. So even without knowing the equations of these lines, I can say that if I plug one in for x and one in for y, it will make both equations give me true statements. All right, so let's take a look at one more. in this one, we have two equations, but they both start off the same. So think about this. If both of these right sides are equal to the same thing, then wouldn't they be equal to each other? Right? Think about that again. If they're both equal to the same thing, then they've got to be equal to each other. So when you have a system where both equations are equal to the same variable like we have here, they must be equal to each other. So then we can set this one up a different way. We can set up this right side of the equation here. The right side of the other equation goes on the other side. They're equal to each other, right? Just like we could write y is equal to itself, then whatever equals y has to be equal to the other thing that equals y, right? They're equal to the same thing. They're equal to each other. So let's solve this equation. I'm going to go with the smaller of my two variable terms, which would be the negative 5x, because that's smaller than the positive 5x. But honestly, you could pick any of the four terms that you want and do the opposite. So the opposite of subtracting 5x is to add 5x. So I'm going to do that to both sides. And then on the left, I'll have 10x plus 15. On the right, I'll just have a 5. All right, now I want to do the opposite of adding 15, or the inverse, right? I want to undo adding 15, so I subtract 15. I bring down my 10x. Over here, I've got 5 minus 15. Or another way you can look at this is a 5 and a negative 15 added together. I like to look at all of it as addition because then it just makes more sense in my brain. So, and actually I'm going to just move this over just a little bit. Okay, so I'm going to have 10x equals 5 minus 15, or a positive 5 and a negative 15 add together to be negative 10. Divide both sides by 10, and I get x equals negative 1. Am I done? No, right? Because the solution to a system is a point, okay? An x and a y. So, what do I do with that x value that I just found? Plug it in, right? So I'm going to plug it in right here. So I'll get y equals negative 5 times negative 1 plus 5. That's going to be y equals positive 10, right? Because a negative times a negative equals a positive, plus 5. Oh, wait, not positive 10? What in the world? Let me go back. A negative times a negative does equal a positive, but 5 times 1 is 5. I was getting ahead of myself there. Then bring down the other 5, and I get y equals 10. So the solution to my system is negative 1, 10, the point. Now, I chose to plug my x value into the second equation. Could I have plugged it into the first one? Sure. That would be 5 times negative 1 plus 15. 5 times negative 1 is negative 5. And negative 5 plus 15 is still 10. Right? It doesn't matter which one you pick, whichever one looks easiest to you. Once you get one variable, regardless of whether it's x or y, it doesn't matter which one you get first. But once you get one variable, you just take it and plug it in to either equation to get the other one. then write them both together as a point. And that's it.